Good day, grade 12s. Today we'll be doing technical mathematics. Then under technical mathematics, we'll be looking at Euclidean geometry. So this is the topic for today's lesson. And then before we can start our lesson, I just want to explain the importance of this topic, that one should have the examination guideline, because for us to be able to answer this question, it needs the reasons, remember, under Euclidean. So that document of examination guideline, it outlines the acceptable reasons that a learner should use when answering questions. So it's better to go and study those acceptable reasons. It's very important, because you cannot write a statement without giving a reason. So if you don't have a reason, you might not get whole marks for that particular question. So the best way is to study before you can go and write your final examination. It's very important. And then let's proceed and see what is under Euclidean geometry. And then under content, we have Euclidean geometry, and this topic, remember, it formed part of paper 2, and then it contributes 40 plus or minus 3 marks out of 180. I mean, out of 150 marks for paper 2. So it's a very important topic that one should make sure that he or she studied very well. And then under Euclidean is divided into 2 parts. The first one is the cycle Euclidean geometry that we did in grade 11. And then now, remember, in grade 12, we introduced to similarity and proportionality theorems. So those are 2 important parts. Now, this one of grade 11, Euclidean geometry, the important things a learner should know. First, you must be able to state all the theorems in words from theorem 1 up to theorem 9, the very important one. And then 2, apply the theorem to solve riders and give the correct acceptable reasons. Like I've said, that we need to know which reasons to use, or the acceptable reasons from that examination guideline. And just knowing the theorems in words, then is going to help you a lot when you have to go and solve the riders. Because every statement, when you are giving a rider, is going to give you a theorem in that scenario. And then because you know the theorem, and of course, knowing a theorem in words, then automatically you're going to understand what does that statement imply for that particular theorem. So it's very important that one should know all the theorems in words. It's very important. So make sure, boys and girls, that you go and study those theorems in words, and also as on how to apply them to solve the riders. All right, cycle geometry theorems, and let's see what we are going to have on this one. All right, now this type of question that you might get for this coming exam is a very important, where you have to complete these statements now, but it's going to be easy for you to complete them only if you have revised all those 9 theorems from grade 11. Then you'll be able to complete this one. All right. Now, the first question that we must have to complete, it says the angle subtended by the diameter at the circumference of a circle is, let's see, is equals to 90 degrees. All right. Number 2, it says the exterior angle of a cyclic quad is equals to opposite interior angle. The third question says a line drawn from center of a circle to the midpoint of a chord is to a chord. is perpendicular to a chord, right? And then the number 4, it says the angle opposite equal side in isosceles triangle are equal. And the last point says the opposite angles of a cycloquad are supplementary. Remember, supplementary means they add up to 180, those opposite angles. So those are one of the theorems that we might get during exam. But remember, these are only few. It's only, I think it's only 5 here. Remember, we've got what? We've got 4 theorems that we need to know on how to state them in terms of weights, right? So it's very important. So here I was just trying to explain or to show you during exam how this question are going to be asked. All right. Now let's get into now solving riders and see how do we solve that. A circle geometry, example 1. Let's see what we are going to have. All right. Now we have to study the scenario together with the diagram. The first says the diagram below shows the circle ABC D. You can see A, B, C, D. You can see all those points. They are on the circumference of a circle. With A, B produced E. You can see A, B produced C. So this line, they just extend it to form that point E. And then AD produced F. You can see there is F there. After extending that line from D, there is point F. And then we have ECF is a tangent. It's a tangent to a circle at C, and then CA bisect A angle E angle AF. Let's see that. Where it's C, you can see the line CA is this one. They are saying it bisect a E angle AF. All right, and then angle C1 equals to 30 degrees. We can see that this angle there is what? Is 30 degrees. And then angle E is 50, is 59 degrees. So that's what we are having. Now, before we can start answering the questions, I just want to advise or to give you an advice per se, but to tell you that from a scenario, you can be able to see how many theorems do you have from this question. The first one, you can see that they were talking about what? A tangent. And then when you go back from grade 11 to check how many theorems that they have a tangent, we have only 3 because it formed part of a group 3 where we are having 3 theorems that has a tangent, right? Now, one of those theorems, if not 2, is going to be applied on this one to answer the questions. And the other point which is very important is this one where they are saying CA bisect. And when we talk about bisect, I believe you understand the words bisect means what? It means that line is going to share this angle into 2 equal parts, meaning this angle A here, which is angle A1 and angle A2, they are going to be equal. Why? Because this line AC bisect that angle, right? Bisect means cut into 2 equal parts. Of course, we are having angle C1 there as 30 degrees and then angle E as 59 degrees. Now let's go and look for the first question. The first question says, give 3 reasons. 3 other angles equals to 30 degrees. You can see this angle C1 there is 30 degrees. Now we have to look for other angles which are also equals to 30 degrees. Now, because this angle, which is at angle C1, it is formed between a tangent and a chord. Therefore, it's going to be easy for us because we will know that theorem speaks about a tangent and a chord. What is happening there? Now, let's see under solution on how are we going to get that angle. The first angle that we have discovered is angle B2, which is 30 there, which is this angle here. Meaning this angle C1 equals to angle B2. What is the reason for that? Is tan chord, right? Is tan chord. Because why we can see that we're having a triangle CBD. So it's formed a triangle, meaning this angle here is equals to this angle there, right? And the other angle equals to 30 is angle A1. Angle A1, meaning this angle here is equals to this one, all right? And then we can say it's the reason also is tan chord because this one, angle C1 equals to angle A1. All right, the reason is still the same, tan chord, but we have another way of answering this question. You can also say angle B2 equals to angle A2. Reason, angle in the same segment, or we can say chord CD subtend equal angles, or we can say arc CD subtend equal angles. Now the last angle is angle A1 equals to 30. What is the reason? CA bisect E angle AF. We're told from the scenario that these two angles, they were bisect, meaning they are equal. In other words, they are equal, meaning angle A1 equals to angle A2, right? So those are three other angles which are equals to 30 degrees. And then number 2, determine with reason the size of angle B1 if angle D1 equals to 61 degrees. Let's see. First, we can say that angle D1 is equals to angle C3. Reason, which is 61 degrees, and reason is angle in the same segment, right? Or if you don't want to give that reason, you can say arc, meaning chord AB subtend equal angles. That's step number 1. Step number 2, then we'll say angle C3 plus angle B1 and 2 and angle A1, they add up to 180. What is the reason? Sum of angles in a triangle. We know that when we add all the angles in the interior angle of a triangle, they add up to 180, or the supplementary. Therefore, because now we have to calculate, remember we are calculating angle B1. You can see there is angle B1 there, and then angle C3, we have determined it. We said is 61. You can see that. Angle B2, remember, we have also determined it from question number 1, it was 30 there. Angle A1, we also did determine that angle, which is 30. So the only angle that we don't have in this case, we don't have angle B1. Then it's going to be easy for us to calculate that. Then we're going to transpose all the other angles to the right-hand side. And then remember, they're going to change the sign. Let me just remove this, all right? And therefore, the answer is going to be 59 degrees. So angle B1 is 59 degrees. Number 3, give reasons why line BD is parallel. They want to know, these people, why these two lines, they are parallel. Now what we discovered is that B1, angle B1, which we've just calculated, which is 59 degrees, is equals to angle E, which is 59 degrees as well. Now, corresponding angles. Remember when we are talking about two parallel lines, and when we're talking about the corresponding angles, they are equal, right? Meaning, if these two angles, they are equal, it simply means these two lines, they are also parallel. And then the number 4 is say determine with reasons whether AC is a diameter of a circle ABC. We want to know AC is a diameter. So it's going to be easy for you to know how to prove a line, whether it's a diameter or not, if you understand that theorem that is talking about the diameter, but only if you know that theorem. But if you don't know, then this question is going to be difficult for you to understand or to answer it. All right, now let's see on how do we prove that. Now we can see that angle, no, this one is supposed to be angle B1 plus angle B2, not 1. It's supposed to be 2 here, it's supposed to be 2 there. We want to add these two angles together, angle B1 and angle B2. If they can give us 90 degrees, therefore we'll know that this AC is the diameter. Remember that theorem that speaks about the diameter. It says a diameter subtend a 90 degrees angle, right? Meaning when we're adding angle B1 and angle B2, it must be equals to 90 degrees. But now we can see that B1, we have calculated, it was 59. And then B2, it was 30 there. And when we add the 2, you don't get 90 degrees. Hence, we are saying angle B1 plus angle B2, this is 2 here, is not equals to 90. Therefore, AC is not a diameter. AC is not a diameter. So don't forget, learners, that this is supposed to be 2 here, not angle B1 again, because now we want to add these two angles, which is B1 and B2, to check whether it's going to be equals to 90 degrees. And then we have noticed that they are not adding to 90 degrees. We have another example. Let's see. A diagram below shows a circle TKLM. You can see TKLM. Those are points on the circumference of that circle with a chord TM and KL produced to meet A at S. TK is parallel to MN with N, a point on KL. Calculate with reason the size of the following angles: angle T, angle L1, and the last question, show with reasons whether MS is the tangent to a circle. Now let's study the given scenario. The important part is this one, where they are saying we have two lines which are parallel. And my dear learners, every time when we are giving two lines from a scenario that they are parallel, you must look whether we are having alternate angles or we are having corresponding angles. The last one, we are having cointerity. Every time when they give you the parallel lines, surely one of those, it must be part of that question, right, or that scenario. The first one is alternate, if there are angles which are alternating there, or corresponding angles, or the last one, cointerior angles. Because there's no way that we can get two lines which are parallel, and then we don't have none of those three points that I've just explained to you right now. So every time you must look whether we have those things or not. Now the first question says angle T, meaning we are in need of this angle here. we have to calculate this angle. And then the only way, what angle that we're having is angle K. And we also have angle there at angle M1, which is 39, and this one is 61 degrees. Now let's see on how do we do that. We say angle K equals to angle N2. We say this angle is equals to this angle here, which is 61 degrees. What is the reason? Corresponding angles. Why? Because these two lines, they are parallel. And we know that corresponding angles are equal, right? Thereafter, then we'll say, then we can see we're calculating this angle L2, right? Then we say N1 plus M1. N2 plus N1. What is the reason? Exterior angle equals to sum of two opposite interior. Meaning when you add these two opposite interior angles, they are going to give us this exterior angle. And then that is going to give us 100, because we can see that angle N2 plus angle M1, when you add them together, is going to give us 100. Therefore, then we'll say angle L2 equals to angle T, which is 100. What is the reason? Exterior angle of a cyclic quad. So that's how you should now determine that angle T. Angle L1, which is this angle here. So there are many ways to calculate this angle L. Now let's see what we have used. Angle L1 equals to 180 minus 100. Angle on a straight line. We all know that angle on a straight line, they add up to 180. Hence we have minus this 100 from 180 there. Then it's going to give us L1 as 80 degrees. And then number 3, show with reasons whether MS, where is MS? You can see is this line here. MS is a tangent to a circle MNL. MLN, this, right? Then surely we have to prove this angle is equals to this one. Tan chord. We're going to use tan chord there. Now let's go. First, we say if angle M2 equals to angle N2, MS is going to be a tangent to a circle MN, only if they are equal. Now let's prove if they can be equal. Then we're going to say M1 plus M2 is equals to T. This, the whole angle, when we add them together, they are going to be equals to this angle T. Reason is the corresponding angles, because these two lines, which is KT and MN, they are parallel. Therefore, M2 is equals to 100 minus 39. Now, where does 100 come from? Remember, we have determined it. It was angle T, right? And then we will also and then we are given that angle M1 is equals to 30. Then we'll calculate angle M2. Then angle M2 is going to be equals to 61 degrees. That is angle M2. Because remember, we are proving that angle M2 is equals to angle N2. Then remember, angle N2, we have also determined it previously. Then it was 61. Then we are saying, therefore, angle M2 equals to angle N2 equals to 60 degrees. Therefore, that is going to be, the reason is going to be tan chord, meaning we have proved that the two, that line MS is a tangent to MNL. Number 3, the figure below models wheel of a sports car with O center point through which axle of a car passes. The wheel touches the straight surface at point D only, BC equals to DC, and C angle DS equals to 40 degrees. The first question, we have to determine what? Determine C angle DB. Where is C angle DB? Let's go and look for that. C angle DB, meaning we are looking for this angle D2 here, because it said C angle DB. So we are calculating this angle D2. We are calculating that angle, and let's see on how do we calculate that. Angle D1. Angle D1, let me just remove this one so that you can be able to see our angle D1. Angle D1 equals to 40. You can see that we are saying angle D1 equals to angle B2. What is the reason? Tan chord. Tan chord, because there is a triangle there which is BDC. Then therefore this angle B1 is equals to angle D1. And then we say angle B1 equals to angle D2, the one that we are looking for, equals to 40 degrees. What is the reason? Angles opposite equal side. Therefore, we have determined that angle, which is angle C, angle DB. We have determined that. Number 2, calculate the size of angle B2. Where is angle B2? Is this one there. Now let's go on how do we determine that. First, we say angle D1, which is 40, angle D2, which is also 40. We have just determined that, meaning these two angles here, the both of them is 40, 40. And then obviously when we add them together, you're going to give us 80. Then you can see it's equals to 80. Then this angle here, which is angle D1 plus angle D2, that angle is equals to angle A. What is the reason? It's tan chord as well. All right, meaning angle A is also 80 degrees. Then we proceed and say this angle here, which is angle O1, is twice this angle here, which is angle A, angle at circumference. Then hence we are having 2 times 80 there. The reason is angle at center is equals to times the angle at circumference. And then angle O1, it gives us 160 degrees. Then we continue and say angle D3, which is this one here, plus angle B2, the one that we are calculating, plus angle O1, they add up to 180. What is the reason for that? Is sum of triangles in a sum of angles in a triangle. They add up to 180. Therefore, because now we have also calculated angle O1, which it was 160, hence we have transposed this 160 this side. So we don't know angle D3, also angle B2. Then the answer that we're getting after minusing this, we're getting 20 degrees. Now, because this angle D3 equals to angle B2, which is equals to 10, each angle equals to 10. What is the reason? Angles opposite equal side. You can see this side is equals to this one, because those are 2 radians, right? So it's 2 radii. They are equal in terms of length. Therefore, the opposite angles of that triangle, they are also equal. And then remember, we obtain 20 there for both. Meaning if they are equal, then the other one is going to be 10 degrees, the other one is going to be 10 degrees. Therefore, we have now determined the angle B2. Number 3, determine the size of angle A. Remember, already we have determined it. You can just say D1 plus D2 equals to A equals to 90 tan cot. Then that's how it was easy for us to calculate that size of angle A. Now we are done with circle geometry for grade 11. We are now into similarity and proportionality theorems. They are saying a line drawn parallel to one side of a triangle divides the other two sides proportionally. A line drawn parallel to one side. Now we are having a triangle in this one, which is triangle AB, BC, and CA. That is the triangle that we were having before, right? That is the triangle that we had before. Now, if we draw a line parallel to one side of a triangle, meaning you can see that we have drawn this line DE, so such that that line DE should be parallel to BC, right? And then just after doing that, we have realized that it divides the other two sides proportionally. Let me just erase. And therefore, meaning this side and this side, it divides those two sides proportionally. Meaning the ratio of this side is equal to the ratio of the other side. But only if we have a line which is parallel to one side of that particular triangle. You can see D is parallel to BC. Hence, we are saying this side and this side, they divide those two sides proportionally. Now, therefore, the ratio are, now let's study these ratios. Let's study the ratios and see what do we mean by proportionality. Now they say AD. Where is AD? Let's look for AD. AD is this one. Divide by DB. Divide by DB. Now you can see that the way we have moved on the left hand side, we must also move exactly the same on the right hand side. Since we said AD divided by DB, then obviously we're going to say AE divided by EC. You can see here is that AD over DB equals to AE over EC. And every time when you write that statement, you must give us this reason that says line parallel to one side of a triangle. You only say these are equal only if there is a line which is parallel to one side of that triangle. Number two, you can see it say AB. Let's go and look for AB. Let me first remove this. Let me first remove this one. AB, let's look for AB. This is AB, divide by AD, divide by AD. Can you see the way we have moved? Must also do the same on the right hand side. AC, divide by AE. Then this is that. Then don't forget to write the reason, line parallel to one side of the triangle. The same with other ratios. You do the same. AB divided by DB, AC divided by EC. All right. That's how you should go about it. All right. And then now you can just remove this. Now we are going to be applying that concept or procedure to answer questions under similarity and proportionality. Now let's see what type of question we might get. Example 1. In the figure below, the triangle PQR has TA parallel to QR. PQ is 28 millimeter, and then PM is to MR is 4:3. So this is the ratio. This is the actual distance. Let us not mix the two. This is the ratio, this is the actual distance. Now, we are given the ratio of PM from here to there. It's 4. Now, to show this is not an actual distance, right? I will just use 4K there because it's not a distance, right? And then MR is what? Is 3. Is 3. Let me just use 3K there. 3K there. All right, it's 3K. Now determine the length of TQ. The length of TQ, which is this one, the length of TQ. Now I have to calculate the length of TQ. Now, I will just give you an idea on how do we answer this question. Every time when they ask you to calculate a length from 2 points, you always start with what we are calculating. For instance, on this one, we want to determine the length of TQ. Then when you start answering this question, you first start with TQ. Divide by what? Divide by 2 points where we are given an actual distance. You can see on this example, we are giving actual distance from P to Q. Now, meaning on the left-hand side, we first move from T to Q, divide from P to Q. So that's how we moved on the left-hand side. So the way we have moved on the left-hand side, we must also move on the right-hand side. Now, the fact that we said TQ divided by PQ, let me just show you. Let me start afresh here. We said TQ divided by PQ. Then on this side is going to be what? It's going to be MR divided by PR. Can you see that? That's how we have moved on this one. So now let's see on how do we calculate TQ. We have started with what we are calculating divided by what is given in terms of actual distance equals to the 2 that is having the ratio. All right. And then don't forget to write the reason, line parallel to one side of a triangle all the time, every time when you have to write this statement. Now, number 2, it says TQ, which is what we need. 28 is the actual distance. And then MR. MR is supposed to be 7, not 4. Remember, it's from, let me check first. Wait. MR. No. MR is 3. Remember, MR is 3K. So it's supposed to be 3 here, not 4. So let us try to rectify this mistake. This is supposed to be 4. MR is equals to 4, right? But not 4 in terms of the distance. That is the ratio, right? Not 4 actually, but 3. Sorry. Let me just remove it. Let me start afresh here. Let's cancel this 4 out because we want MR. And when you go back to the diagram here, we can see that MR is what? Is 3K. So hence it's going to be 3 there. Divide PR. Let's look for PR. PR is from up there until to this point. So what is the distance there, or the sum of what? Of the ratio? Then it's going to be 4 plus 7, 3, then it's going to be equals to 7. Then we have to have 7 there, not 3. Right? Not 3. Now we'll have to recalculate this question, but I hope it's not going to give anyone a challenge or a problem. Then we're going to fix that. Then from there, we're going to cross multiply. Right? Let's cross multiply. Remember, this TQ is no longer multiplied by 3, but what? 7 now. We're going to multiply by 7. And this 28 is no longer multiplied by 4, but it's going to be multiplied by 3. Right? And then now we're going to say 28 multiplied by 3. It gives us 84. It gives us 84. When you multiply 28 times 3, it gives us 84. Divide by what? Remember, we are in need of TQ. Then we have to divide both sides with the 7. Then this is going to be divided by 7. 84 divided by 7, which is equals to what? Which is equals to 12 millimeter. This is supposed to be 12 millimeter. All right. This is supposed to be 12 millimeter. Sorry, this is supposed to be 12 millimeter. Can you see that? So this is not the correct answer there. Just cancel it out. We have cancelled it. Also this one. I hope my dear learners will understand the error that was happening on this one, but everything is correct now. The answer, the correct actual distance for TQ is what now? Is 12 millimeter, but not this one, because we just make a mistake of writing 4 instead of 3, and then here instead of writing 7 we wrote 3. All right. Next question. In the diagram below, triangle KLM is drawn. C and Q are points on KM. B and P are points on KL. BC is parallel to QR and parallel to LM. And BQ is parallel to PM. KM is equals to 15 units. And then PL is equals to 4 units. And the ratio that we're having is KQ is to QM, which is 3:2. Determine the stating with reasons the length of QM. Let's look for QM. Let's go. Here is QM. Now remember, every time we start with what we are calculating, then we have to start with QM. Then divide by what? Divide by the side or 2 points where we are given the actual distance. You can see the actual distance is 15 units there, which is from K to M. So we said QM divided by KM. Then we'll have to move the same way we have moved to the other side. And that other side, it must have 2 lines which are parallel to each other. Now let's look on how do we calculate that. We said QM. We can see QM is what we are in need. KM is the actual distance, equals to now QM, right? QM over KM, length parallel to one side of a triangle. Now, QM is what we need. 15 is the actual distance. Now, QM, you can see QM is there, which is 2 in terms of ratio. And then KM is 5. KM is from here up to there. It's 5 because we say 3 plus 2, it's going to give us 5. Then we do cross multiply them, and then 15 times 2 is 30. Then we're going to divide both sides by 5. Then it's going to give us 6 units. That is the actual length from Q to M is 6 units. B, number 2, I mean, it say KP. Where is KP? KP is this one here. We have to calculate that distance. Then we're going to say KP is what we are in need of, divided by PL is where we're given what actual distance. We can see from P to L is 4 units. Then the way we have moved just on this side, then we have to move the same way to the other side, which is KQ. Where is KQ? You can see here's KQ from here, and then QM is there. Then let's see, actual distance for PL is 4 equals to KQ. KQ is what? Is 9. How do we obtain that 9? Remember, we have determined the distance of QM, it was 6, and the whole distance from K to M, it was 15. Therefore, we are going to say 15 minus 6. Then it's going to give us 9 there. The distance of KQ is going to be 9. All right. And then, of course, QM, the one that we have determined, is 6 units. So it's 6 there. So let me just clean this one so that we can be able to see. And then you do cross multiply. Then after you do cross multiply, then you say 4 times 9 is going to give us 36. And then we divide both sides with 6. Then it's going to say 36 divided by 6. Then it's going to give us 6 units. So that is the actual distance for KP. That is that. And then we have the third example. We are still under similarity and proportionality. Let's see. In the diagram below, triangle PQR is drawn with S on QT. I mean PQ, sorry. T and V on PR and W on QR. ST is parallel to QR and VW parallel to to PQ. Furthermore, PS is to SQ in terms of ratio is 1:3. Then RW equals to 4 units in terms of actual distance, and then QW equals to 5 units in terms of actual distance, and then PT is 3 units actual distance. Of course, TV is what? Is X units in terms of the actual distance. Now, the first question that we have to answer, it says determine with reasons the length of TR. Where is TR? This is the TR. Then I repeat myself. You always start with the side that we are looking for. Divide by the side where we are giving the actual distance. You can see that the actual distance which we are having is from P to T. Then you can see the way we have moved on this side, which is TR divided by PT. We must also move the same way on this side, because why? This line ST is parallel to QR. Let's see if that is the case. Yes, TR divided by TP equals to SR divided by SP. Line parallel to one side of a triangle. Second step, the actual distance 3, and then remember SQ. You can see SQ is here. It was 3 in terms of ratio, and then SP or PS, the same. SP or PS, it was 1. Hence, you see 1 there. Thereafter, you do cross multiply, then the answer is going to give us 9 units. You multiply 3 times 3 divided by 1 is still 9. So it's 9 units, TR. That is the actual distance for that. Number 2, express VR in terms of X. Where is VR? this is VR. This is VR. We want it in terms of X. We have to express it in terms of X. Now, since we've got X from T to V, and then we also have the actual distance from T to R, therefore, we are going to say TR minus this TV, that is going to give us this VR, but it's going to be in terms of X. You can see the answer is 9 minus X. So that is the length for VR in terms of X. And then 3, give the numerical value of VR over VP. Where is VR? Let's go and look for that. Let me just clean our diagram first. Now let's look for VR. Where is VR? VR is this one, divided by VP. Divided by VP. We want that. Now the way we have moved on this side, we must also move the same way to the other side. Now, since we have done with this side, where we are having a line ST parallel to QR, we are now looking for this one, where VW is parallel to PQ, meaning this side here, PR, is equals to this side here in terms of proportionality. Now let's see on how do we do that. First, we're going to say VR over VP equals to what? Equals to RW. RW. The way we have, remember we said VR divided by PV. Then we're going to say WR, or we can say RW divided by WQ, right? Therefore, it's going to be 4:5. You can see the actual distance there is 4 from R to W, and then from W to Q is 5. Therefore, the answer for that one is 4:5, because we were asked to determine the ratio, not the actual distance per se, but the ratio for that. And then don't forget to write that reason all the time that says line parallel to one side of a triangle. Now the last question says, hence determine the numerical value of X. Numerical value of X. We want to know what is the actual length for X. We don't want to see that X anymore. Let's see on how do we do that. Now first, we are going to say 9 minus X. Why 9 minus X? Remember, for V, let me first erase these lines. And then, all right, now VR, remember VR or RV, it was 9 minus X. In terms of X, it was 9 minus X, right? 9 minus X. Divide by 3 plus X. Where does 3 plus X come from? Which is VP. Remember, from V to P there is the distance is 3 plus X, that X, right? All right, equals to RW, it was 4, WQ, it was 5. Thereafter, you state the reason, and then from there, we are going to cross multiply. Instead of writing RV, we have substituted with 9 minus X. Instead of writing VP, we have substituted with 3 plus X. Equals to, instead of RW, it was 4, and then WQ, it's 5. Therefore, the next step, obviously, we're going to do cross multiply. Then this is what we are getting after cross multiplying. Therefore, we're going to open the bracket. 5 times 9 is 45. 5 times negative X is negative 5X. And then 4 times 3 is 12. 4 times positive X is 4X. Then we're going to transpose the other one on the other side, and then the X to X. Then if we bring this 4 positive 4X to the left hand side, then it's going to give us negative 9X. And then you also take this 45 to the right hand side to be added with this 12, then it's going to give us negative what? Negative 33. Then you divide both sides. Since we are in need of x, we are going to divide both sides with negative 9. Then after dividing, then you are going to obtain as x as 11 over 4. So that is the value of x. And then the other question, the picture below is part of the roof truss. You can see there is a roof truss there. The diagram next to it is present a part of the roof truss where M is any point on the side, PO of triangle PQR. MN is parallel to PR with N. On QR, MC parallel to PN with C on QR. QM is to MP, which is 3:2 in terms of ratio, and then the actual length for CN is 2,8586. Calculate correct to 1 decimal the length of QC. Let's look for QC. This is QC. Then remember, you start with what we are calculating. Then we're going to say QC divided by CN. Why CN? Is because CN, we are given the actual distance. Remember, I said to you, you start with what we are calculating, divide by a side which is where we are given what? The actual distance. And it was 2,86 equals to QM, because now you can see this CM is parallel to NP. Therefore, the way we've moved on this side, then we must also move the same way. That this is going to be QM divided by MP. And then remember, QM were given in terms of ratio. It was what? It was 3 K in terms of ratio, and this one it was 2, right? Hence, and then from there you state the reason. Hence, you can see 3/2. Then you do cross multiply. Why 2,9? Because they are saying we should now correct to 1 decimal. Then I just converted this into 1 decimal. Hence, we can see that it's 2,9. Then you do cross multiply, and then 2,9 multiplied by 3, it gives us 8,58. Then you're going to divide both sides with 2, then it's going to give us 4,3. So that is the actual distance for QC. Now the length of NR, where's NR? This is NR. You start with what we need, then divide by the actual length. NR is what we need, QN, meaning QN is from here. Let me try to clean this once. All right. Now QN, meaning QN is from this point to this one. Now remember, we have determined QC. We have also been given the CN. Then we can just add the 2. Then they're going to give us 7.98. I mean 7.2. We said 4.3 plus 2.9. That is give us 7.2. And then PM is 2. QM is 3. Then you do cross multiply, divide with cross multiply, meaning 7,2 times 2, it gives us 14,4. And then there we're going to divide both sides with 3, then it's going to give us 14,4 divided by 3, which is 4,8 centimeter. That is the length of NR. The last one, in the diagram, triangle M and P with R on MP and T on MN is given such that RT is parallel to PN, S is point on PN such that TS is parallel to MP, MR is 10 units, RP is 4 units, MT is 8 units, RT is 9 units, TN is X units, the last one SN is Y units. Calculate the state with reason the value of X. We need the value of X, meaning we need the actual distance for what? For TN. Then we always start with what we are in need, divide by the actual distance. The actual distance on that side you can see is what? Is 8. Therefore, this is what we have to see. Tn, which is X, Tm, which is 8, equals to the other side. And you can see even the other side, we're having what? PR there, or RP, which is 4, and then PRMR, which is now 10. Then this is what we're going to be seeing. Then we cross multiply there, and then we divide with that. It's going to give us 16 over 5, which is 3,2 units. That is the value of X. The same question, we now have to calculate the value of Y in this case. We are now calculating this Y. Now remember, we start with what we need. Now first we say PS. Where's PS? PS, this one is equals to RT, which is 9 units. Y. PRT is parallelogram. Remember, opposite side of a parallelogram, they are equal. Hence, PS is 9 as well. It's 9 units there. Therefore, we say NS divided by PS. So the way we have moved, we must also do the same, which is TN and TMT. Then you cross multiply. You can see we substitute. From there, you cross multiply. The value of Y is going to be 3,6 units. 3,6.
Oh my guy.
And then from there, you substitute, and then after that, you just cross multiply. Then the value of Y is going to be equals to 3,6 units. So that is the value of Y. That's how we should now determine the value of Y. All right, thank you very much for being with me on this very interesting lesson. I hope everything, it will make sense. And then for you, grade 12s for technical mathematics. And then this is a message for today's lesson, my dear learners, that says, I have seen your struggle and dedication for exam. Do not stress, take your time and do your best. I believe that you will do everything well. All the best for your exam, the incoming exam. All the best, boys and girls. Thank you very much. Have a nice evening.